Hi, my name is Bing Han and I am the history professor for Hydroelectric Dam.
Is it a good idea to build a hydroelectric dam in Mississippi? Oh, excuse me, my name is Tan Yisen and I'm the president of the United States of America. Well, I guess I have to hear the voice of our engineers and scientists behind this project.
Oh, hi there. My bad, ours is my too. My name is my husband. I'm the engineer here who's mentoring the operation of Hydroelectric Dam.
Now, I'm going to tell you the history of hydroelectric power, the technology to take advantage of falling water and get mechanical energy is old. The Greeks used water wheels for grinding wheat into flour more than 2,000 years ago. Besides grinding flour, the power of the water was used to saw wood and power textile mills and manufacturing plants. In 1831, the first electric generator was invented by Michael Faraday. This laid the foundation for us to learn how to generate electricity with hydropower almost half a century later in 1878. The first electric dam, located in Appleton, Wisconsin, began to generate electricity already in 1882. The power output was at about 12.5 kilowatts, and in 1936 the Hoover Dam was opened and generated 1,345 million watts from the flowing water in the Colorado River. During the first half of the 19th, hydropower became the world's most important source of electricity. Hydropower is considered a mature technology, contributes about 16% of global electricity generation today and will contribute even more in the future. There is almost 30 major hydroelectricity projects with at least 2,000 million watts capacity under development, and most of which are located in China. Now, let's talk about energy. What exactly is energy? Energy can neither be created nor destroyed, but it only can be converted from one to another. What about gravitational potential energy? It is one type of potential energy comes from the Earth's gravity. Gravitational potential energy is the energy stored in an object based on its height and mass. Okay, now let me show you the formula for gravitational potential energy, where m is the mass of object, g is the standard acceleration of gravity, which equals 9.8 meters per second squared. The height is determined based on the height of the object could potentially fall. Here is an example for potential energy. When the ball at the highest position, it has the highest potential energy value. When it's falling, the potential energy decreasing gradually. As it's falling, the energy changes to other energy. So, let's move on to kinetic energy. Kinetic energy is the energy an object due to its motion as long as the object is moving at the same velocity, it will maintain the same kinetic energy. The energy of an object is calculated from the velocity and the mass of the object. We can use this formula to calculate the kinetic energy, where m is the mass and v is the velocity. Example for kinetic energy. When the balls start rolling down, the potential here is converted to kinetic energy, and the kinetic energy is affected by the mass and the velocity. As the mass increases, it creates more momentum. Therefore, the velocity also increases.
Let me take over the most important part here. Those were simple ones. And you probably never heard of electrical and mechanical energy. Now, let's talk about mechanical energy. Mechanical energy is an energy that is possessed by an object due to its position or its motion. It's kind of confusing, but let me introduce you the formula of mechanical energy. Here's the formula. Mechanical energy equal to potential energy plus kinetic energy. So basically, it's a sum between potential energy and kinetic energy. Now, we know that energy cannot be created nor destroyed. If potential energy increases, the kinetic energy decreases. And it happens opposite way when kinetic energy increases. Let me show you the example of how mechanical energy works. Now, I refer to the roller coaster. When the roller coaster is at the highest position, it has the highest potential energy, which is 10 joules, and the kinetic energy is at 0 joules because it's not moving. As the roller coaster is going downwards, the 60% of the potential energy is converted to the kinetic energy, which then leave potential energy at 4 joules. When roller coaster at the second lower part of the route, the 80% of the potential energy is then converted into kinetic energy, which leaves potential energy at 2 joules. When it's going upwards back, the 20% from the kinetic energy is then converted back to the potential energy, which gives the same value as is right here, because the roller coaster has the same height, which gives them the same value of potential energy, and so therefore the kinetic energy has the same amount as well. When roller coaster finally goes at the lowest part, the potential energy gives the 0 joules, and the 100% of the energy then converted into kinetic energy. Next, let me explain to you the electrical energy. On the other hand, electrical energy is the scientific form of electricity, and it refers to the flow of power or flow of charges along a conductor to create energy. So basically, it's like a mechanical energy. It's the rate of doing work that is measured in watts. However though, electrical energy is known to be the secondary source of energy, which means we obtain electrical energy through the conversion of other forms of energy. For example, water, natural gas, nuclear energy, coal, or even oil are the primary energy that we use to create electrical energy. Let me show you the formula of electrical energy. Now, we know that electrical energy is the rate of doing work measured in power, which is P. P equal to V times with I. V is known as the voltage, and I is known as the current, which is in ampere. Passive device is one of the examples. When positive charges move through the potential difference from positive terminal down to the negative terminal, the work is done by charges in the device.
Alright, so now we know that hydroelectric dams benefits us a lot. Once a dam is constructed, electricity can be produced at a constant rate. For example, if electricity is not needed, the sluice gate can be shut, stopping electricity generation, so that the water can be saved for use for another time when electricity demand is high. Furthermore, dams are designed to last for many decades and so can contribute to the generation of electricity for many years and decades. The leaks that forms behind the dams can be used for water sports, leisure, or pleasure activities. Often large dams become tourist attractions in their own right. On the other hand, the leaks in water can be used for irrigation purposes. For example, the build-up of water in the lakes means the energy can be stored until needed, when the water is released to produce electricity. And when it's in use, electricity produced by the dam system do not produce greenhouse gases, and they do not pollute the atmosphere.
However, the disadvantage is that constructing hydroelectric power plants and dams is very expensive. It requires large area. Another disadvantage is that planning a hydroelectric plant and reservoir may lead to the disruption of the lives of people living in that area, as they have to reallocate to another area.
Oh, sorry, I was looking through to the new project of Hydroelectric Dam. Talking about dam, don't you think it's a miracle how water can convert into electrical energy? Don't you wonder? Well, let me explain to you how is this work.
Scientifically, water stored in the dam will flow to a connecting pipe which connect the dam to a generator. The water are affected by the potential energy which caused by the Earth's gravity. As a result, it creates a high current of water to flow through the connecting pipes. When water is released, the potential energy are changed into kinetic energy, which form a high current water and will cause the turbine to rotate at high speed. The kinetic energy of the water will be transferred to the turbine, and later the shaft connecting to the turbine will transfer all the kinetic energy to the generator to change into kinetic energy. The kinetic energy of the water will be transferred to a turbine, and later the shaft connecting to the turbine will transfer all the kinetic energy to the generator to change into mechanical energy. Then, this energy are converted to electric by the concept of magnetic field through the cutting of magnetic flux. Electric energy are stored in a powerhouse and will be connected to the national grid. This process will be repeated again as the water went through the turbine will be transferred back into the dam.
The reason why we build such a massive and tall wall is because we want to increase the production of electricity. You see, first, the wall has a particular shape. This is because to withstand the pressure that is being applied by the water. No matter what shape they are, the wall always has to be thicker at the bottom. This is because according to the pressure formula, which is mass times gravity times with the height, the water has a greater pressure at the bottom. Imagine how strong the wall has to be holding 1,000,000 gallons of water behind it. Well, thankfully to the engineers who made an accurate calculations and estimations. Next, we built a control gate in front of the penstop. This is enable or blocks water from flowing through towards the turbine. In the middle of the penstop, we place a trap which is purposely to filter off all the obstacles such as rocks which have potential to damage our turbine. Now, let me explain to you the different types of turbine. There are 3 main types of turbines. One is called pattern turbine, which work the best at the low rate of water flow. The second is called coupling turbines, which work the best at high rate of water flow between 70 to 800 cube per second. The third one is called Francis turbine, which work the best at the medium rate of water flow. Now, in most of the dam, we use Francis turbine is because, as you can see on the graph here, the Francis turbine work efficiently at a wide range of operating conditions. The reason why we use Francis turbine in most of the dam. Now we know about the turbines, but how they convert the movement of the turbines into electricity, which is the kinetic energy into electrical energy. Inside the generator, there is the main component called rotor. The rotor covers 360 degrees with the electromagnets. The rotor is powered by the direct current. Even though when the gate of the generator is closed, the rotor will still spins and creates rotating magnetic fields. As it spins with the stator, the magnetic field acts on the winding. Each time when the pole makes one revolution, one pulse of alternate current is generated on the windings and then to the grid, also known as a wire, which will carry the electricity away to your house. It is still in fact in a complex form.
What is the advantages of hydroelectric dam to the society? Alright, with the development in the electronic technology today, most equipment operates on electric power. Improvements in this area observe an expansion in economy. For example, the building of the hydroelectric dam itself provides thousands of job opportunities, from constructing the dam to operate and maintenance. This also requires knowledge and expertise. Thus, this helps improve the society incomes and as a result improve the quality life of the society.
Okay, that was persuasive by Hazwan and Chai. So what are the environmental effects of building hydroelectric dam? Firstly, there are 3 Georges dams. According to some, has the potential to be one of the China's largest environmental nightmares. They said one of the most immediate environmental effects of the 3 Georges dams has been an increase in landslide activity. This results primarily from erosion caused by drastic increases and decreases in reservoir water levels, which, when in their peaks, creates a body of water almost as long as Britain. Another major issue with the dam is the ways which it is affecting the biodiversity in the area. Animal and plant life has been greatly threatened due to flooding in habitats and water diversion in others. Furthermore, fragmentation of habitat may lead to heavy losses of biological diversity. Well, now I think we should build a dam in Mississippi. And now I would like to make a gesture of appreciation to my team, to Chai, Azwan and Mahmoud in the lab for helping me on this project. And now I'm looking forward to this new dam in Mississippi.
Thank you.
Thank you.